Hey guys, so now we're going to look at graphing rational functions with linear expressions in the numerator and the denominator. Rather, y equals ax minus b all over cx minus d. To graph these types of functions, we're going to determine the locations of the intercepts and asymptotes first, and then we're going to use those as a guide to sketch the graph. So graph the function y equals 4x minus 5 all over x minus 2. Identify any asymptotes and intercepts. So the first thing that we're going to do is we're going to find out what the x and y intercepts are. If you remember from way back when, my x-intercepts occur when y equals 0, and my y-intercepts occur when x equals 0. So we start off with our function y equals 4x minus 5 all over x minus 2. We'll start by finding my y-intercept. And my y-intercept occurs when x equals 0. Doesn't matter the order that you find these in, it's rather arbitrary. We're just starting with y for funsies. So if x equals 0, that just means that I substitute 0 in for all of my x's in my original function, which will give me y equals negative 5 all over negative 2, or rather y equals 5 over 2. So that tells me that I'm going to have a y-intercept at 5 over 2, or rather a y-intercept at 2.5. Just because I have my graph right here, we'll fill that in right here, and at just 2.5, I'm going to indicate my point right there. Now, my x-intercept. Well, finding my x-intercept, we know that y is going to be equal 0. So I substitute the 0 in for the y, and I get 0 equals 4x minus 5 all over x minus 2. From here, there's two ways that I can handle this. One of the ways is I can just look at the numerator, and if I look at the numerator, I can realize that the numerator is the only thing that matters when we're equating a rational to 0 because the denominator just makes it undefined. Or if you want, we can multiply both sides by x minus 2. X minus 2 multiplied by 0 is 0. X minus 2 multiplied by 4x minus 5 over x minus 2 just gives me 4x minus 5. So I get 0 equals 4x minus 5. Moving my 5 over to the other side, I get 5 equals 4x, or rather I get x equals 5 over 4. Now from here we know that the 5 over 2 was approximately 2.5. Or not approximately, it actually equals 2.5. We'll just draw the equal sign right there. And my 5 over 4 is just going to equal 1.25. So I'm going to indicate my x-intercept right here at 1.25. Moving on. To reveal the location of both the vertical and horizontal asymptotes, we must manipulate the equation of this function algebraically to obtain the form y equals a over x minus h plus k. So my initial function is y equals 4x minus 5 all over x minus 2. Y equals 4x minus 5 all over x minus 2. From before, we realized that we need to get the matching, and I need to find a way to cancel that x minus 2. So 4 multiplied by negative 2 is negative 8, which will give me 4x minus 8. Remembering that I must add the 8 and then minus 5 all over x minus 2. I capture my first two, 4x minus 8, plus 8 minus 5 is plus 3, all over x minus 2. I then factor the 4 out, 4x minus 2, all over x minus 2, plus 3, all over x minus 2. Separating my fractions right there. That gives me the cancellation that I'm looking for, and I get y equals 3 all over x minus 2, all plus 4. So looking at it in this form, what this tells us is the x minus 2 tells me I have a horizontal translation of 2 units to the right. Or rather, my vertical asymptote is at x equals 2, because I have that non-permissible value that x cannot equal 2. The 4 right here, well, this tells me that I'm going to have a vertical translation of 4 units up. Or rather, my horizontal asymptote is going to occur at y equals 4. Now, the a value right here, when we look at that 3, well, that does tell us that we have, we're just going to go down here. That does tell us that we have a vertical stretch by a factor of 3. At this point in time, it's going to be kind of hard to really show that on the graph because we don't really have many points that we can transform on our rational function. So what I'm going to do is what I call the crosshairs method, and we're going to start by writing the horizontal and the vertical asymptotes on the graph. We already have the x and y intercepts, and as it stands, that's actually going to be enough information to get a good picture of this graph. My vertical asymptotes at x minus 2, my horizontal asymptotes at y equals 4. So I have my horizontal asymptote, which is going to be at y equals 4, and I draw in my dotted line to represent the horizontal asymptote. My vertical asymptote is at x equals 2, so I draw my vertical asymptote in with that dotted line. Now, the reason I call this the crosshairs is because these two dotted lines create something that looks like a crosshair. From here, my bottom piece, I see that it goes through both the x-intercept and the y-intercept. And it's going to be approaching the asymptotes from either side. So that's my first time trying to draw it. I did not do a good job. We're just going to quickly erase that. We're going to quickly erase that piece. And I'm going to give it one more try here. Sorry, drawing on a tablet is kind of funky for me. So I'm still learning it. There we go with the arrow. And there we go with the arrow. That's not too bad. Now, as it stands right now, we're just going to know that the next piece is drawn in the opposite quarter. We'll talk more about that and how we know that later, but all that I'm going to do is I draw this piece right here, and it comes down, and it goes like that. I obviously do not have a steady hand, but that little bump right here is not going to occur, so we'll just straighten that out a little bit. And that is what my graph is going to look like.